In this video, I am going to be debugging an LLM generated application, a chess application that is going to enable me to feed multiple chess games into the application. And it is going to be extracting the chess games based on my requirements. And you don't have to understand chess at all for this video, but I'm going to show you what we are going to be doing. So for example, here we have a list of games and we can actually download all these games. And what this is going to provide us with is that, for example, here we have 19 games. So that means we are going to have 19 different PGNs as it's called. And what a PGN is that, and I'm going to open this up in Visual Studio Code. And here, as you can see, for a game, we are going to be having a text file, again, in the format of a PGN. And here we are going to have certain metadata as well as the chess moves that have been played and on which time they have been played, so on and so forth. And my objective with this project is that I would like to extract the games that have transitioned into an end game. And what that means is that, for example, if I go over and open this game up, what you're going to see is that, and I didn't memorize this, I just looked that up. Here on the board, we have only 2 bishops and 2 kings. And again, you don't have to understand what bishops do, what kings do. No chess knowledge is required for this one. But the thing you have to understand is that we don't have that many different pieces on the board. For example, here at the start, we are going to have lots of different pieces on the board. And most of the games are actually going to end before an end game. So for example, if I go to the last move of this particular game, you're going to see that we have different types of pieces on the board, and that's not a pure end game in the context of chess. So what I would like to do is that I would like to be able to extract the games that have been transitioned into an end game so that I can study them. And not only that, I will have 2 other conditions that are going to be required to met. And one of them is that, and I am going to try to find the same game again. I suppose this one was the game we are looking for. The first condition that I'm going to be looking at is that after the transition into the end game, as we can see here, I would like this chess game to have continued for, let's say, for 15 more moves so that I have some positions and moves that I can study. And the second thing I will be looking for is that if I open this up, you are going to be seeing an computer evaluation of this position. And in chess, this means that at this very position, black is actually winning. And a rough threshold would be, I guess, 1. What that means is that if the computer evaluation is between 1 and -1, it means that the game is pretty much the equal. But if the computer evaluation is greater than 1, that means that white is very likely to win. White is in a winning position. And vice versa, if the computer evaluation is less than -1, then by the same logic, that means that black has a winning position. So in this case, black is already winning when we have transitioned into the end game. And as we are going to see, the player with the black pieces has actually won. And this is not something I would like to be studying. I would like to see either games that were pretty much close, pretty much drawish in the context of chess, and then somehow one of the players managed to win, or vice versa, in the sense that one of the players were in a winning position, but they messed up. They either lost the game or drew the game. And that's pretty much all you're going to need to know about chess in order to be able to follow this video along. So I'm going to go back to IntelliJ, and here we have 2 Java classes, 2 LLM generated Java classes, and these classes have been implemented by LLMs using this Python file. And this file is called endgame extractor because I have been using this Python script for a long time now. But as I myself is not a Python developer, I don't have fine-grained control and understanding over what's happening here. So I decided to implement the same thing in Java. And as I was doing it a couple of hours ago, I realized that this could actually be a very helpful content because I will be working with a project that I'm not entirely familiar with. I am going to be debugging this application. I am going to be refactoring this application and making engineering design choices. So I thought this might be very useful. So all that being said, I am going to go back to the IntelliJ idea. And first of all, we are going to get to know the project, and also we are going to be resolving the compilation issues. As of now, as you can see here, we have 56 errors that are going to prevent us from compiling this Java Spring Boot application. And the first problem is that we are actually trying to use an external library, but currently Spring Boot is not able to recognize and retrieve the content of this particular library. So I'm going to go back to my pom.xml file, which stands for project object model. And first of all, here I am going to try to find this external dependency, which is not there. So I am going to go ahead and copy this one here, and I'm going to Google this, and this will hopefully redirect me to either Maven repository or the GitHub repository itself. So I'm going to go ahead and type this in, and what we are going to see is that, okay, we have the GitHub repository, we have Maven repository. I'm going to start with this one. And here we are going to be seeing certain building and installing instructions. And what the author has shared with us is that you can actually declare this one, or more particularly this one, as one of your repositories. And when you are going to add this dependency, you are going to be good to go. So we are going to try that. Here in my pom.xml, I am going to be pasting this in under my dependencies. As you can see here, I am working with these dependencies. And now this chess library is supposed to be one of them. And secondly, we are going to be using this, or again, more particularly, more correctly, we are going to be declaring this repository. So here I am going to paste that above my dependencies and try to synchronize Maven changes. And what this is going to do is that this is going to reconsider our dependencies. And in this case, we have added a new dependency called the chess library. And the project build tool Maven is going to try to retrieve the content of this library, which are basically a set of pre-implemented classes, into our own application. So if I go back here, we are going to see that this import related issues are gone. And if I go ahead and, for example, try to go inside this, we are going to be seeing that we have a class, we have a board class with a content that would have otherwise taken us maybe weeks, maybe months to implement. And we can actually use that out of the box thanks to two things. First of all, obviously, the author of this chess library that have been implemented with Java. And secondly, thanks to the fact that we are using Spring Boot and Maven as the project build tool. But of course, Gradle, the alternative of Maven, would also have achieved the exact same thing. And what they do is that we didn't have to lift a finger in order to be able to retrieve this set of Java classes, set of pre-implemented Java classes that exists within the chess library we are going to be using. All we did was to declare our dependencies here. And if I go ahead and find these external libraries here, and I am going to be looking for this group ID. So I'm going to go ahead and open this up. And here, as you can see, we have this bitboard, we have this board that we just take a look at. We have various enums, interfaces, and classes, and all of that comes out of the box. And again, we didn't have to lift a finger. So I'm going to go back and I am going to be closing these down. And here in this PGM processor, we have two more errors that we are left with. So the first one is that this board variable that is an instance of this board class does not actually have a getBoard method, so I assume the LLM has hallucinated, so we are going to have to fix that. And secondly, the second error we are going to have is that this load move text actually throws an exception, so we are going to have to either handle that or we are going to have to add this exception to the method signature as the IDE is going to suggest us. And if I scroll right a bit, you are going to see that. And I am going to close this down for a second and undo the changes. And when I go ahead and click on this add exception to the method signature, we are going to be seeing that we now are going to be declaring that this method analyze game may throw an exception. And by that, this is no longer a compilation issue anymore. So the only one we are left with is this one. And here I am just going to add a to-do item. And I'm going to type in replace board.getBoard with whatever it is meant to be. And here, in order to be able to get this application up and running with no compilation issues, I am going to be commenting out this part of code block. And now I suppose we are going to be able to run this application properly, though this is not going to work out well, I suppose. So here we have a PGM processor class that implements a command line runner. And what this is going to do is that after the Spring Boot application has started, this particular method is going to be running. So I am going to be adding a breakpoint around here. And I'm going to go ahead to my main application class and try to debug this application. And we are going to see what happens. And we are going to be seeing our first issue. Okay, no such file or directory, and it cannot run the program stockfish. I suppose we have this in our YAML file, but I am going to make sure that, okay, here we have this application YAML file. And if I look for chess.stockfish.path in the Stockfish service, we are actually supposed to be providing a Stockfish path. And Stockfish is one of the most popular chess engines out there. And what it does is that what chess engine means is that, as you can remember here, we have certain computer evaluation numbers based on the position that we have on the board. And what chess engines do is that they take these positions and then they evaluate them using certain criteria and then provide us with these numerical values. So in order to be able to evaluate certain positions within our Java application, we are going to be needing an engine, a chess engine. And in this case, this is going to be Stockfish. So I'm going to go ahead to my terminal. And now that I am connected to a MySQL server here, and I don't want to lose that because I'm not sure if I will be using any database just yet. So I'm going to make it slightly smaller and press Command N to create a new terminal window. And here I am going to be, okay, I would not like to update this one. Here I am going to be typing in brief install Stockfish, and this is going to be installing Stockfish on my behalf, and I suppose this is going to be on this path, but we are going to be checking that out as well. And I suppose this is going to take a while until it downloads every single package it needs. And okay, now that it is ready, I am going to type in which Stockfish, and this is going to point to opt homebrew bin Stockfish, which exactly matches this path over here. So I'm going to go ahead and try to debug this application again. And it is going to tell me that we already have an application on our computer that is listening on port 8080. So I'm going to go ahead and find that project. I suppose that was this nutrition project that we did just a couple of days ago. So I'm going to stop that and go back to my chess application. And we didn't actually have to do that. I could have as well come here and at the end of this file, server colon port colon 8081, let's say. And if I try to debug this, then this is going to start on port 8081. Hopefully, I am going to be able to demonstrate that. I'm not sure though. Here, console. Okay, our Tomcat web server started on port 8081, but we are going to be using the default one. So I'm going to stop my application, delete this now, and try to debug my application. And here, as you can see, after our chess application has started, which is the name of this main class, we have landed in this run method in this PGM processor class, because this PGM processor class is implementing this command line runner interface that is provided by Spring Framework itself. And here I am going to go back to my threads and variables. And here, okay, after the two logs, we are going to be using a PGN input path, which is currently not the case on my computer. So I'm going to stop this now. And I am going to go ahead and here down below, I am going to be finding this download all games. And when I click on this, this is going to be providing me with a PGM file that is going to contain every single game in this round. So I'm going to close this down, and in the Finder, I am going to be copying the name of this and come back to my ID. And ideally, you would do that if you were to use that in your application. You would actually store this file under your resources path, or more specifically under your static folder. But in this case, I will be trying out the functionality first this way, and then I am going to be trying to implement an API, a REST API that is going to be taking a multi-part file. So I'm not going to be bothering taking this file into the static folder and then loading that resource using certain annotations. And that is the reason why I am going to be using this kind of primitive approach at first. And here I am going to be typing in the name of this PGM, which is going to be a little bit different. And here I am going to be typing in my username. So if I go ahead and debug this again now, and here I am going to be jumping right into line 41. And if I go ahead, and we are going to be seeing that this PGN is actually full of data, it actually includes 19 games. So we can conclude that so far this actually works, because as you can remember, we also had 19 games in this round in this Lichess website. So I'm going to go back, and here what we are doing is that, okay, we are creating a new hash map with the key piece type, and we are going to be holding a list of games. And what I understand from is that I suppose we are going to be using this for saving separate results. So I'm going to go ahead and find the save results method that is going to be taking this results map as a parameter, and it is going to be iterating through every single piece type, as you can see here. Then this is going to create different PGM files. You can think of them as text files as well if you're not very familiar with chess notation and chess files. And I suppose that that is the reason why we initialize the hash map like this at the start. So I'm going to go ahead to line 47 because here we are not going to get any errors because these 5 lines are not dependent on any sort of data or any other external service. So this is just going to be a basic Java operation. And just by looking at it, we can tell that this is not going to fail. And here what I see that we are holding a count variable in order to be able to print out the number of processed games once in a while. For example, in this case, once every 50 games, but I'm not going to be using that. So I am going to remove them and I am going to be checking if I have any compilation errors just to be sure because here although this method ends right here and I can look line by line if this count variable has been used again. Sometimes you are going to work with and sometimes you are going to be refactoring some methods that are going to be much longer than this. For example, here, if I try to remove this and okay, right after that, we are going to be using that. But what you do is that, for example, you try to remove these 2 lines because you for some reason think that this is redundant. You either have to go through every single line and see if there are any errors, or what you can do is that you can basically click here and this is going to lead you to the point where the compilation error is going to occur. So I'm going to undo my changes because we are actually going to be needing them. And now that the code changed, the debugger might not be working as intended. So I'm going to stop this and rerun this in the debug mode again. And here, as I can tell, we don't have to stop on these lines. We are going to come here and I am going to be clicking on resume program. And here I am going to the next line. And here we are going to have a game variable because now we are iterating through every single game that is going to be returned by this getGames method, which comes from the PGN holder class that is again provided by this external library. And this is going to be returning us a list of games. So here, as we are going to be iterating through every single game in this debugger, I am going to be able to see that which game we are actually going to be analyzing. And in order to be able to debug what's going on in this analyze game method, I don't actually have to find this and then set a breakpoint here, so on and so forth. But what I can do here is that I can come here and find this button with the overlay text step into, and this is going to be taking me into this analyze game method itself, because otherwise if I were to try to go to the next line as I was here, this would then take me to this line. But I also would like to be able to inspect what is going on here because this is actually the most important part. So as you can see on the bottom part of my screen, we are currently inspecting a game between these 2 players, and if I go back to Google Chrome, this is the first game we have. And as you can see here, I am at the end of this game and there are lots of different pieces on the board. So this should not count as an end game. So we are going to inspect what this code is going to do. First of all, this is going to be loading move text, whatever that means. I am going to go inside this, but okay, this is not going to be extremely clarifying. So I'm going to go back here. I suppose that is going to do something internal with the game instance we have. So I'm going to go ahead and here we are going to be initializing a new board. And as you can see here, we have already a human readable format. So this is actually the exact representation of what you can see here. Okay, maybe not here, but I'm going to not only refresh my page, but I'm also going to repair my internet connection. So if I refresh this, you're going to see that we have R, which stands for rook, then we have N, which stands for knight, so on and so forth. And this board is going to be representing exactly that, and decide who is to move is white. So this is a very readable way of what we have as a Java object. So here we are going to be going through every single move line by line. So what this is going to do is that, as I can understand, this is going to move this one and this is going to check this particular position and try to understand if this is an endgame. And for that, I suppose we are going to be using this that detect endgame method. And then if not, this is going to be playing out another move and then another move and then another move just to be able to iterate through every single move that has been played. And if, for example, in this case, after 99 moves, we still don't have an end game and we don't have any other moves, then this is going to classify as a game that has not transitioned into an end game. So I'm going to go back And I am actually going to go line by line. And here I am going to be stepping into this detect endgame method. And here we have the code block that we have actually commented out. So we are going to have to find a substitution to what LLM tried to generate. So what this is going to do is that, or what this method is supposed to be doing is that it has to go through every single square. In this case, for example, after the move one, it should go through every single one of these squares. And if there are more than one type of piece on the board other than the pawns and the king, then it should not classify as an endgame and we should skip that. So I assume we are going to have to use this board object somehow. So I'm going to right click and click on evaluate expression to be able to debug this application, or more precisely, to be able to play out with this board object that we have at hand. And as you can see here in this debugger, this particular board object is actually representing the board after the first move has been played. So here on the debugger, you can see that this pawn has moved here. So this is now empty and black is to move. And that is the exact case here in this board as well. So I'm going to go back and I am going to type dot to be able to explore what's inside. So for example, we have a castle right method, which is going to be returning us an enum map. And what this is going to represent is that white still has the option of castling both king side and queen side, and black has the same too, but you don't have to understand this, so I'm going to skip that. So here we have event listeners, history, and I suppose this is going to give us, okay, I don't understand what this is. I am going to skip that. And if I don't get to find what I'm going to need in this method, then I am going to try to go through the documentation if that exists. Okay, if I scroll down a bit, get backup, get en passant, get history. Okay, we have get piece and get piece location methods that we can actually very reliably use. So what I think is that first of all, we can actually go through every single square and then we can create a variable that is going to hold every single piece that is going to be existing on the board. That could be one approach. So for example, if I go ahead and find the square class as well, which is going to be in enum, okay, here, for example, I can go through every single one of them. And as you can see here, when I evaluate this expression, this is now going to be returning me a white rook, which is the case in this position in A1. As you can see here, there is a white rook. So the very least I can do is that I can go through every single square and then try to create a map or some sort of variable that I will have to think of and then try to make use of it. And one other thing is that I am going to be typing in get piece location for this. And I suppose piece is a form of enum as well. So I'm going to go inside this. Okay, here I suppose we are going to be able to get query by typing in this piece. And this is going to provide us with two, one on A1 and one on H1, and that is the case. As you can see here, we have two rook. But for example, if I look for the black queen, then this is going to be returning us D8, I suppose. So I'm going to type in black queen, and okay, this is going to provide us again with a list, but in this case there is only one element, one square element, and that is going to be D8. So I'm going to go back to the chessboard now in order to be able to see it more visually, and I'm going to try to design a system that is going to be efficiently able to tell if a position is an endgame or not. So the very least I can do is that I can go square by square, and maybe I'm going to take a random position so that it's more realistic. So it might actually go square by square, and here we have a rook. Okay, we still have a rook, and I am going to be ignoring kings and pawns, and then I am going to go through this one, and then here if I see a bishop, then this is not a pure endgame. So this might be a reliable way of approaching this project. So the other approach would be if I were to use the second method we have used, this get piece location method, what I could do is that I could try to look for, okay, if this is a rook endgame, I might look for rooks for both sides, and if they exist, then we can go through the other pieces that they do not exist. But I suppose that is not going to be very beautiful, and that is actually a very good question if you like to work on your algorithmic skills. But my intuition says that, and in a real life project, I wouldn't be trusting of my intuition, just to be clear with you. I am going to be iterating through every single square, and I am going to be implementing an algorithm that is, for example, in this case, is going to be able to understand that this is not an endgame position after about 20 or 21 iterations. And if there is an issue with my approach, I suppose we are going to be able to find out when we are testing this application. So I'm going to go back and actually I'm going to close this down because I am going to be writing lots of code and then we can try to debug that together. So okay, that's actually very smart. That is actually very useful. That is what I would have been implemented in the first place as well. So we are going to be start with a fresh state and we are going to be going through every single square and we are going to be checking if any of these pieces exist on the board. So I'm going to go back and I am going to be removing these redundant comments. And here I am going to be partially writing my own code, but partially using this LLM generated code as well, because I suppose this is going to be proving useful for us as well. So what I need is that I need to iterate through every single square using this board variable that we have here. So first of all, I am going to use the square enum, I suppose. And every enum has a method called values by default, by Java's default, and this is going to be returning us a square array. And I like to work with lists instead of primitive arrays, so I'm going to type in arrays and then as list, which is going to be taking this array as a parameter, and it is going to be returning us a list of something. In this case, this is going to be returning us a list of squares. So in this case, we are going to have an array list that is going to be containing every single square that you can see here. But as I was closing this, I have seen this none. I don't know what the use of this, so I'm going to remove that actually. So I am going to assign this to a list of squares and name this all squares available. That's tomato, tomato. And here I am going to be looking for the method called remove. And here I am going to be removing this non-square, which I don't see any use for. And here in a stream or a direct for each block, what I can do is that for every single square, I am going to do an operation. So first of all, we are going to be needing a piece that is going to represent the piece that might exist on that particular square. Because remember, we are iterating through every single square right now within this for each method. And here I am going to use this get piece method of this board class. And as you can remember, this is going to be taking a square as a parameter. And this is going to be returning us a piece that is going to occupy that square. So I suppose there should be something like none, because in chess you might have squares that are going to be empty and that has to be represented in one way or another. So I'm going to go back to my PGM processor. So first of all, I am going to be getting every piece that might exist on every square. So here I am going to be using some of the logic below because this is going to be useful. So what this does is that, first of all, this is going to be looking for either this piece is a king or a pawn, which we would like to ignore, as well as if there is nothing on that square. And here I'm going to name all of these p's, the variables named p as p's, so that it can match the variable name I used here, or else I can make this p, but I don't want to do that. And there is a cool trick that I like. Instead of going through every single one of them, I am going to make this p. And now that all of them are matching, I'm going to go ahead and rename this as P's so that I don't have to go through every single one of them. And now that I think about it, there is actually a much better way of achieving the exact same thing. I mean, maybe not much better, but I suppose that will be much more easier to read. So here in this class, I am going to be initializing a new class variable, and we are going to be holding a list of pieces that are going to be ignored when analyzed. So here I am going to be creating a new list using the static arrays as list method. And here I am going to be typing in piece.none, and then we are going to be typing in, okay, if I scroll down a bit, we are going to be seeing that, okay, this is not a piece, this is actually a piece type, and this is actually being referred in the piece enum itself, I suppose. Okay, as we can see here, every single piece also has a site, let's say, or a piece types, and this makes perfect sense. Props to the person who have actually developed this one. So I'm going to go back here. We are going to be initializing a list of piece types, and I am going to have to rename this as well. And here we are going to be ignoring piece type none. We are going to be ignoring piece type king, and finally we are going to be ignoring, if I can manage to, here we have the piece type pawn. So what I can do here is that instead of checking them one by one, I can just use this piece. okay, this has to be all caps by conventional reasons because this is a static class variable. So I'm going to rename that as, and as you can see here, the IntelliJ is actually suggesting us that we use all caps as well. And I am going to be using piece type to be ignored. And down below, I suppose we are going to have a compilation issue. Here, I am going to be using that piece types to be ignored list. And I am going to be checking if the piece type of this piece variable that we have on the square. So for example, to make this as visual as possible. Now what we are doing is that we are iterating through every single square. So we are, let's say, starting with A1. And then what we are going to be doing is that we are going to be getting the piece that might exist on that square. So in this case, this is a rook. So what we are going to do next is that we are going to be looking at this list of piece types, which as you can see here consists of none, king, and pawn. And we are going to be looking if rook is one of them. And if that's the case, we are going to be continuing with our, okay, not continuing, but we are going to be returning here. And if not, if this piece is something we should not be ignoring, then I am going to be using the switch statement and we are going to see if this is actually correct. Here I am going to be, okay, first of all, we are going to have to import these static constants and I don't want to do that one by one. So instead of that, I am going to come here and import all of them and we are going to see certain issues. Okay, first of all, I'm going to make this piece. And now that we are in a lambda expression, as you can see here, this is a lambda expression within this for each method. We are not actually able to reset these variables and this is not going to compile. And one thing you can do is that first of all, you can use something like this. You can use a primitive for loop and you can actually go through every single square that we have within this all squares variable that we have initialized here. And then you can take this piece of code that is within these curly brackets and put them here. And this is now going to work just fine. Or not, because now you're going to have to use keywords such as continue and break. Or one other thing you can do is that you can create a map and then for the keys you might have bishops, knights and rooks and queens and that would look something like this. You would have a new map and the key is going to be a piece and the value is going to be a boolean, so on and so forth, but I'm not going to bother that much. And after looking at every single square, what we are going to have to do is that, for example, here I will start with this rook or more particularly this square A1, then okay, we only have a rook, then this is fine. We are going to be looking at this is none. We are going to ignore this. And then here we are going to be looking at the Boolean variables that we have here. And we are going to see that two different types of pieces exist on the board. So this is not an end game. So what we are going to have to do is that, and I am going to delete these ones. And here we can actually use the logic that have been provided here. So what this is going to do is that this is going to convert every single one of these Boolean variables into ones and zeros in the form of an integer. And in order for a position, in order for a board to be able to classify it as an endgame, the exact number should be 1 because we should only have bishops, let's say, or let's say we only have knights on the board. So what we are looking at is that, for example, here we have various different pieces on the board. So has rook variable is going to be true, so this is going to evaluate to 1. And has bishop variable is going to evaluate to 1 as well. So even before we have to check for if there are knights on the board or queens on the board, we can say that, okay, the number of types that have been found is not 1, then this is not an endgame, so we can return null. So I suppose here we are going to be checking for nulls. Okay, this is an interesting way of approaching matters, but I suppose this is going to work. So I'm going to take this up here because we don't want to be doing that after we have gone through every single square because this is going to be very much inefficient. But still, I'm going to do something called defensive programming and I am going to be adding this to-do item debug properly because this might be resulting in some edge cases that I might not be able to foresee as of now, but we are going to debug that and see if that works properly. And then we are going to be removing these redundant lines. I think this is very much self-explanatory. And now that we don't have any compilation issues, we can actually try to debug this application again. And here we are going to be getting the first game again, and I am going to step into this method, and we are going to go a couple of lines. We are going to make our first move, so we are looking at this particular board. And here I am going to step into this method again, and we are going to be initializing these variables as false. We are going to be getting all the squares, but notice that we have 65 of them, although we have a board that is 8 to 8. So it is supposed to be 64, but we are going to be removing the square none. And here, okay, maybe not, then we are going to be seeing what's happening here. So if I scroll up a bit, we are going to see that this operation was not supported. And the reason for that that is that's actually something I forgot. This static as list method is going to be returning a list that is going to be unmodifiable. And as you can see here, this is going to throw an unsupported operation exception, as you can see here on my console as well if we try to modify that. So for now, I'm going to adopt a much more primitive way. And if all of this works out, then we are going to find a way to make this much more beautiful and maintainable in the long run. Here I am going to be iterating through every single value now that we are no longer working with a for each method. And here I am going to be checking if the square equals to square none, not a1. And then we are going to be continuing if that's the case. So I'm going to remove this line. And now that this variable is redundant, I am going to remove that as well. And now I am going to debug this application. And now that I have a breakpoint here, I am actually going to remove that one. And here we are going to land in this detect endgame method. So I'm going to line by line. And as you can remember, again, we are looking at this particular board right now. So here we are going to be iterating through every single square. So the first one is going to be A1. And I suppose that is because that is the first value in this enum as well. And in this A1 square, we have a white rook. So I suppose we are going to be getting a piece that is a white rook. Okay, so far so good. And here what we are going to be checking is that, and I am going to evaluate this expression just to be sure. Here we are going to be getting this piece type, and this piece type is a rook. And we are going to be checking if this piece type to be ignored contains this rook, which shouldn't be the case. Okay, then this is going to evaluate the false. So we are going to go ahead and run through this switch method. And as you can see here, we are going to have to set this rook, has rook variable to true, which is what we like. So I'm going to go ahead one more line. And here the types found is going to be equal to 1. So this guy is going to now evaluate to false. And this is correct, but I suppose we are going to have to either change this or we are going to have to evaluate this after we have gone through every single script. So I'm going to think that through just for a moment. Okay, I think I got it. What we are going to have to do is that, and I'm going to, okay, not remove this one, but what we are going to have to do is that if the types found is greater than 1, then that is going to mean that this is going to have found more than one type of pieces, then we don't have to search no longer. But if this is 0 or 1, it has to keep going to make sure that we check for every single square. So after the switch method, okay, I'm going to try to make this as visual as for myself as well. So imagine that we had started with this square. So the number of types that have been found would have been 0. And in this case, we would have been telling the application that this is not an endgame, but we can't tell that. So for example, if I go ahead to one of the endgames here, now what we are going to see is that if we start from A1 here, then this is going to, and by this I mean to this integer variable, this is going to be equal to 0. And now this is going to be evaluating to true, and then we are going to be returning null, which is going to mean that this is not an endgame, but we can't tell that just yet because we haven't gone through every single square. But what we can do here is that we can actually interrupt if we see more than one piece of types, then we don't have to go through every single square. So I'm going to go here, and here I'm going to be returning null if the number of types that have been found is greater than 1. But otherwise, we are going to be going through every single square. And right after that, and if the number of types found never exceeds the number 1, then we are going to look at these variables because this might as well be a position with, let's say, only kings. If I go ahead here and exchange these pieces, and for example, if we look at the sport and go through every single square, what we are going to see is that the types found is still going to be 0, or let's say relevant types found is going to be 0. So we are not going to be able to return null here, but we are going to go through every single lines here. And for this particular board, none of these are going to be true, so we are going to be returning null. Okay, I think we found the correct approach, so I'm going to delete this. And here, remember that I had actually imported every single piece type as a static value, so I can actually delete these as well so that it looks much more cleaner. We are going to be returning rooks and queens and bishops and knights, and if we have our breakpoint in place, I am going to be debugging this again. So okay, we are going to be ending up here. As you can see, this is now the board we are going to be working with, and I am going to make this visual again, not just for you but for myself as well. So here we are going to be initializing the variables, and then we are going to be getting the white rook that exists on the square A1. And then here we are going to be seeing that the number of types found is 1, but this is going to evaluate the false. So I suppose we are going to go through another square. Now we are looking at B1, which is going to be occupied by a knight. So I'm going to go ahead and we have found this white knight. And here we are going to set this has knight variable as true. Now this number of types found variable is going to be equal to 2. And if I try to go ahead and go one more line, we are not going to be landing here because this method is now going to be returning a null. So if I click here, we are going to end up in this line that have called this method detect endgame. So I'm going to go one more line. And now that the detected type is null, this is now going to evaluate the false. So I suppose we are going to be getting to the next move. So realize that we still have the exact same position here. We only have a pawn in the middle. But in the next move, we are going to have another pawn in the center. So I'm going to come back here and I am going to make a move. And if I open this up now, we have two pawns in the center and it is actually white to move again. And this is going to call the detect endgame method again, so on and so forth. And currently I don't see any issues with our detect endgame method. So what I'm going to do is that I am going to set a breakpoint here. And I would like this breakpoint to enter when the condition is that detected type does not equal to null. So it actually has a value, or much more simpler than that, I could have also introduced a breakpoint around here. So I'm going to remove that and I am going to resume my program and I am going to be removing this one as well. Okay, we have had some issues and the reason for that is in this line, the return value of this was null. So what we are going to do is that we are going to be introducing a breakpoint here. So here I am going to be adding the condition piece.get piece type equals to null. So when it's null, I would like to stop here and inspect what is going on. So I'm going to debug this application again. And here we have a position in which, as you can see here on B1, we have nothing. So the piece type evaluated to none, or sorry, the piece evaluated to none. And if we go inside this and look for none, we are going to see that this piece type is null. So what we are going to do here is that to handle that or intervene before it exists, but I suppose this should have been interrupted here. So piece type none, it is actually a type to be ignored. Okay, now I think I understand because the piece is none, but the piece type of this none is actually null itself. So here in this piece types to be ignored, we are going to have to introduce a new element null so that it can bypass that as well. So I'm going to stop this, debug this application again. And here we are going to land at this particular line. And what we are going to see is that this application now found an endgame, or more precisely, a board that is going to be containing a rook endgame. So I'm going to go ahead and try to view this. Okay, we have kings, pawns, rooks. And actually what I can do is that I can find this game between these two players. I'm going to look for Alexander. Okay, here we have one Alexander. And here in this debugger, I'm going to look for the move number and I'm going to divide this by 2. So I suppose we are looking at move 38-ish. Okay, now this is going to be the end game position that we are going to work with. So I'm going to go back to IntelliJ IDEA just to be sure. Okay, now black is to move. And if I come here, okay, this is, as you can see here, I can move this black piece, but I cannot move this because now this is black to move. And here I am going to take a brief look at this board to see if they match. Okay, we have pawns, pawns, rooks, pawns. Okay, this looks pretty much the same. And as I mentioned at the start of this video, I still have two more requirements for these positions. The first one is that there should be at least 30 more moves so that I can study them. For example, here, okay, we have transitioned into an end game, but let's say after 2 moves, let's assume that this game ended. This is not going to be helpful for my chess study, so I would like to ignore that. So what I'm going to do is that, first of all, we are going to be checking if the number of moves that have been played here after this move that we have seen here, we have rook takes knight, and now we are in an end game. We are in a pure end game. And as you can see here, this is move 39, and we have moves up to 51. So the game ended in about 24 moves, which is not ideal for my case. And I'm going to look for if my application can actually handle that. So I'm going to go ahead and evaluate this expression. And okay, first of all, we have moves.size, which is going to be the exact number of moves that have been played in this game because both sides have played 51 moves. So this is fine. And if I undo that and evaluate this particular expression. Okay, now we see that the number that I have calculated and mentioned previously, this is the number of moves that have been played after this particular position has arisen on the board. So we would like to ignore this. And as you can see here, this is now going to evaluate the false. So if I go ahead and move one line, this is going to bypass all of these lines, and this is going to end this method. So this analyze game method is not going to be evaluating the position or doing anything with the results variable that is going to be passed into this method. So I'm going to go ahead and find the one where we can actually land in this stockfish service dot get evaluation line. And here, okay, I don't think I have to rerun that. So I'm going to resume program. And okay, here we are landing at a position that, as we can see from the debugger, this must be a bishop endgame. And if I go ahead and evaluate this expression, which is going to evaluate into the number of moves that are going to be played after the endgame position is reached. So this is going to, okay, true, but how many moves is the number I am wondering? Okay, apparently 66 moves more have been played after the endgame is reached. So what I'm going to do is that, first of all, I am going to make sure that this is actually true. So first of all, here we have this game between these players. So I'm going to go find Maximovich, and based on this variable, integer variable, I suppose we are looking at something around 57. Okay, here after this move, now the bishop ending has been arrived. And right after that, we are going to see that both sides are going to make 33 moves each. So it is going to evaluate that number that we have just seen, 66. So this is nice. But what I'm wondering is that I would like to see this number, or a number that is going to be similar to this one, when I evaluate this expression itself. And what this is going to do is that our application has detected that this position is the position of interest for us. And as I mentioned, the second requirement, in addition to the number of moves that are going to be played in that end game, is that I would like this game to be very close, and then one side manages to win, or one side has a crushing advantage but somehow messes it up. So in this case, from a computer perspective, this means that black has a crushing advantage, but they also won this game. So I suppose there are not going to be much to learn from this game. So I would like to ignore this. So first of all, I am going to come back to my ID and evaluate this expression. And here we are going to be calling our own service using this board.getFan. And just to make it more visual, what I can tell you is that this board.getFan is going to be returning us a one-liner, a one-line string. And if I copy that and go ahead, analysis board in this Lichess website, and paste this here, we are going to be seeing the exact same board. So this is just an internationally conventional way of notating chessboards. So there is that. So what we are going to be doing here is that we are going to be using that one line of string that is going to be internationally accepted, and we are going to be passing it into this stockfish service get evaluation method. So I'm going to go ahead and run this, and we are going to see that this number is actually quite different from, okay, this gets growing over time. I don't know why. But the thing is, if I come back here, you can see that the evaluation of Lichess engine, which is also stockfish, if I'm not mistaken, this is actually close to minus 3.3. But if I go inside here, this is now going to show us that this is actually the evaluation that was concluded after 8 seconds. So what I'm going to do is that, as you can see here, we have a move time in milliseconds, which is going to be retrieved with this value annotation from our YAML file. So I'm going to go ahead and make something different. And here I am going to be using the exact same value and try to debug this application again. And here we are going to land at the exact same line for the exact same players, and I suppose for the exact same board. As you can see here, we have a bishop and then two pawns. And if I come back here, that is the case. So I'm going to go ahead and evaluate this expression, because the computer evaluation is extremely sensitive in my case. So I'm going to evaluate this expression, and we are going to be waiting for 8 seconds, but that is fine for my use case. And okay, this is now much more close to what we have actually seen here in this website, and both of these are going to mean that black has a crushing advantage. So if I come back to my ID, close this down, and I am going to go just one line to see what this is going to evaluate to, and we are going to have to wait another 8 seconds, because what you do in the debugger, what you do in that evaluate expression window, does not apply to the state of your application. And okay, now here we are going to be having an evaluation of minus 3.45, which I think is much closer to what we have here. And here we have a method called is interesting. So I'm going to go inside that method as well. And now that we have two methods here, one of them is interesting method, and then we have the get result method. The IDE could not choose between which one to go to. So I'm going to go here and set a breakpoint here, and then resume this program. And here we are going to see that the score was, the computer evaluation was this one, which means that black had a crushing advantage. And the result is black won. So this should be evaluate to false. So here we are going to be going line by line. Okay, we get the value of this enum. I don't really see why. And then we are going to be getting the absolute value of this evaluation. And okay, here what we are going to check is that we are going to see if this absolute value is less than 1, which is going to mean that the game is actually very close. But then we are going to be checking if one of the sides managed to win. And I really don't see why we are going to be needing a string variable here. So I'm going to actually stop this now and then try to refactor this using the beautiful capabilities of Java enums. I don't see any reason why we don't use these beautiful enum values and instead we are using these descriptions. I again suppose that is the part the LLM has hallucinated. So I'm going to delete this one and right away we are going to have lots of red lines, but we are going to have to fix that. So the first condition I would like to return true is that, which is going to mean that this game is of my interest and I would like to keep that. I am again going to be creating a array list using the static as list method. And here I am going to be passing in white one and I'm actually going to open these side by side. Here I am going to be passing in white one and black one. And I'm not interested in games that have been drawn or is still ongoing, but I don't think that is going to be the case. And I am going to be checking if this particular list is going to be containing this result. And just like that, you could have also written something like a big parentheses and then inside that result equals white one or result equals black one that is going to do the exact same thing. But I think it's much more cleaner this way. So I'm going to make this a little bit narrower and scroll left here. So the second one that we are going to be looking at is that if the score, and I don't really want to name the score, so I'm going to rename this to eval, which is a common way of shortening evaluation in the context of chess. And I am also going to rename this as well, apps eval. And here the second case is going to be that white has a winning advantage, but they didn't actually manage to win. So we are going to check if result, and I'm going to use an exclamation mark because we are going to be checking if result not equals to white one, and we are going to apply the same logic here. So I'm going to copy this here, paste it down, and instead of white one, we are going to be looking for if the evaluation is below -1. For example, in this case, this is -3. This means that in the chess context, black has a winning advantage and they actually managed the one. So this is now of interest. And the idea is going to be telling us that we can actually simplify this if statement by returning this right away. But I think this is a much more readable way of implementing this method. So I'm going to leave that as it is. And I actually think that these 3 lines are pretty self-explanatory. So I am going to be removing these redundant comments as well. So here I am going to be debugging this once again. Okay, here we have the same game. So I am going to go one more line. Okay, the position again evaluated to something that indicates black has a crushing advantage. So I am going to resume this program to be able to, okay, or not. So I'm going to stop this now. And I am going to be adding a new breakpoint here because we have removed one of these lines. So our breakpoint have been gone as well. So I'm going to debug this now. And you already know the drill. I am going to step over to see the evaluation if that's right. And I suppose that is going to be right now that we have been trying it for a while. Okay, now this is again evaluate to black having a crushing advantage. So I'm going to resume this program to be able to land in this is interesting method. And here, if I go ahead and compute this absolute evaluation value, we are going to see that these two conditions are going to evaluate the false. And now that we have an AND operation here, the idea is not going to care about the rest either. So I'm going to go ahead and jump to the third condition. Okay, this time around, this particular condition is true, but result, as you can see here, actually equals to black one. So this expression, including the exclamation mark, is going to evaluate the false, and hence all of this going to be evaluating the false. So we are going to go one more line, and this method is interesting, is going to be returning false. So what I would like to do here is that I am going to find the method in which we are going to be saving these results. So I'm going to set a breakpoint here and resume this program. And I'm actually quite surprised that we have results with the size 4. So I'm going to inspect them as well. Okay, now that makes sense because this size actually refers to the number of keys that exist in this hash map. And as you can remember, as we were initializing this results map, we actually had put these various keys, and I am going to be removing these as well just to make sure that it is much more visually appealing. So regardless of the outcome, regardless of the PGM files that that we are going to be providing this application with, this hash map, this results hash map is going to have 4 keys. And then based on the data we provide, then the size of these array lists that are going to be corresponding to every single one of these pieces may or may not change. In this case, all of them are 0, so this is not going to be doing anything. And by that, I mean that here in the save results method, we are never going to be able to land in this line because every single one of these expressions is going to evaluate to true, so we are going to be returning without doing anything file related operations. So I'm going to resume my program, and as you can see here, we are not going to be jumping and landing on this particular line. And if I go back to my console, what we are going to see is that we have this analysis complete log that is going to be printed after we have saved the results. So what I'm going to do is that I am going to change the content of this particular file without making a more comprehensive test. What I'm going to do is that I'm going to open this up, and I hope that I'm going to be able to use IntelliJ for this. Okay, now do remember that we had a game between these two players that actually transitioned into an end game, but we didn't include that because at the moment the game transitioned into a bishop end game or an end game of any sort, the black was actually winning and black won the game. So what I'm going to do is that I'm going to tweak this result parameter, and I'm going to manipulate this data in a way that this PGN now assumes that white won. And here at the end of this line, and I know that because I'm very much familiar with PGM files, I have been working with them over 2 years now, I suppose. And here, now that I have changed these two values, what this PGN is going to represent is that white actually has won. So if I go ahead, and I'm not sure if this is going to be auto-saving, so I'm going to close this and open it up again. And okay, it seems like it has saved. So I'm going to stop this application now. And instead of debugging this, or not, okay, maybe not. Okay, I will debug. So here in the Stockfish service, now I am going to be looking for is interesting method. Okay, we already have a breakpoint here, so I'm going to debug my application. And after a while, we are going to be landing here, and I am going to remove this one. We are not going to be needing that anymore. And I suppose this is going to take some time because every single Stockfish evaluation is going to last 8 seconds as we have specified here in this application YAML file. So I'm going to go back here. And as you can see here, I suppose this is still the same game because in this whole PGM file that we fed this application with, there is only one single endgame transition after which there have been played at least 30 moves. Now this time around, we are seeing that white won because we manipulated that data. So I'm going to go line by line, and the first two conditions are going to evaluate the false again as expected. So I'm going to go here, but this time around the result white won does not equal to black won. So this is going to evaluate the true as well. So we are going to be returning true as a result of this is interesting method. And if I set a breakpoint here, what this is going to do is that this is called the get property method of the game class, I suppose, that has been provided by the chess game. Okay, I don't know what this does. I suppose, as you might remember, as we have seen here, we have certain properties. I suppose this is going to add a new one, but we are going to find out together. And okay, this is going to add a new property called event, and I assume this is going to be the method of the map. Okay, so here, as you can see, this property variable in this game class is a map itself. So what we are going to have to do is that first we are going to need to specify the name of that key of that map. So here in this case, maybe I should not close this down in the first place. Here we have this event. I suppose instead of this one, we are going to be seeing this particular string that is going to be evaluated, and I'm going to evaluate that actually to make sure that it is what we are anticipating. Okay, learning bishop start something, and this is not going to be useful because we have to divide that by 2. But okay, I'm going to keep that as it is. So here we are going to be going one step forward. And what this is going to do is that, as you can remember, we have a map called results. Currently, we have no elements in any of these keys. And this is going to get the detected type. And detected type is bishop. As you can remember, this is now the bishop endgame. So this is going to get results.detected type, in other words, bishop. And currently, this has no elements in it. So it is going to use this add method of this list interface. Because as you can remember, as we were initializing this map, we have put bishop as the key, and then we have initialized an empty array list as a value. So if I go ahead and resume, now we are actually going to land in this one, I suppose, because now we have actually a game that need to be written as a file. So if I go ahead to the variables, we are going to be seeing that in this method, and I was hoping that we would have been seeing this result. So I'm going to evaluate expression now. Now, although we don't have any queen end games, rook end games, or knight end games that have met the two other requirements, we actually have a game of a bishop ending. So this is going to handle that hopefully successfully. So I'm going to resume that and go into my console. Okay, apparently it saved the game to this PGM. So I'm going to find this and open this up in IntelliJ again. And if I go ahead and look for learning bishop, okay, it didn't replace this, but we have this learning bishop start 100 something. And if I go ahead and copy this, and I am going to go to analysis board, as you might remember, here I am going to be pasting in this PGN. And with that, without having to go through every single one of these games and try to find material that I can study, I will actually get this one. And here, if I scroll up a bit, okay, the metadata is gone, so I'm going to paste that again. Okay, here start 116, so I suppose we are looking at move 50 something. Okay, here I can from now on start studying my end games. And this might sound absurd to you if you are not familiar with chess, but chess is actually a beautiful game that requires lots and lots of studying. It takes a couple of days to understand the basics, but it definitely takes at least a lifetime to master the every aspect of the game. So this is why I have been trying to develop this application, to be honest with you. But still, there are a couple of things that I would like to change here. First of all, I don't want to be using my application YAML in order to be able to upload these files. So I'm going to go ahead and type in Spring Web Maven repository so that we can work with REST API so that I don't have to readapt my application YAML file every single time I would like to work with a new PGM file. So I'm going to go ahead and find the Maven lines required for this one. Okay, Spring Framework. This is not the one I'm familiar with, so I'm going to go with the Spring Initializer, and there are a couple of ways to achieve the exact same thing. And here, after adding dependencies, I'm going to click on Explore to see what the Spring Initializer would have provided me with, and this is not the one I'm familiar with either, so I suppose this is a version difference. I am going to try that again. Okay, this is the one that looks familiar. So I'm going to take that here to my POM.xml so that we can have access to various annotations, and as I was saying, we already have dependencies, so I didn't have to bother. So I'm going to go ahead and create a new class called PGN controller, and actually I'm going to create that under the package controller. So first of all, here I am going to be typing in implement REST API with multi-part file input. And the second one is that, as you can remember, here after having pasted this actually started from the start, and I'm not interested in the start of this game, at least most of the time. And what I had to do is that I had to paste that in, find that line, do the math, and then go through this game to find the exact moment where the position of interest has actually arrived. So what I would like to do is that I would like to get such a PGN that it is going to be starting from this exact position, and this is going to be removing the moves that have been played previously. And I'm not sure about the PGM format of that one. So before coding anything else, I am going to have to try a couple of things. If I'm not mistaken, I should be able to do something like, okay, here I am going to be looking at the metadata format here in this IntelliJ, not anywhere else. And here in this PGN, okay, we can see that we can provide metadata in this format. So I'm going to go ahead and add in curly brackets, and then I am going to be typing in this one. And after that, I am going to be providing the moves that start with 59, King F2. So I'm going to search for King F2, not 3, and I am going to be taking this one. And here I'm going to paste that in and then copy that just in case. And okay, this is not going to work out. So I'm going to go to ChatGPT and I'm going to ask, why does the following PGN not work? And I suppose that is going to be providing us with a satisfactory answer. Okay, as it turns out, we were missing these quotation marks. So I'm going to go back and try to do the exact same thing. I'm going to refresh the page, and then here I am going to be providing in these. And okay, this is actually going to work. This is now going to start from the move I like, maybe a move later, but still this is a good start. So if I were to be able to get that as a PGN, that would be awesome. So I'm going to go back to my IntelliJ and we are going to try to see if this is possible using this chess library. So I'm going to stop this application now. And here in this PGM processor, I'm going to find the line where we add the game. Okay, here we add the game. So with the breakpoint already in place here, I am going to debug this again. And here I'm going to be evaluating certain expression and try to see if I can get to create the PGN that I just manually created. So here I am going to skip the is interesting part. And here, okay, we have the exact same game. So what I'm going to do is that to open up this expression evaluator, and I'm going to make this bigger because we are going to be here for a while. And if I'm not mistaken, we are going to be adding this game. Okay, so I'm going to arrange my screen in a way that I can see them both. And then here, I suppose I can do something like put FEN. As you can remember, that's the one we have used here, but then we are going to need this notation here. So I'm going to go ahead and get fen maybe. Okay, this is going to return null. Maybe board.getFen is going to be what we are looking for. And I'm not going to be checking every single character. So instead, what I'm going to do is that I'm going to type in diff checker. And here I'm going to be providing the one that I got from IntelliJ. And here the one that I have retrieved from the Leech's website. So here I am going to be finding difference and hopefully the texts are identical. So I'm going to go back. So I suppose what I should be able to do is that I should be able to add this fen property. And here I am going to be using get fen, but I am going to be commenting this out for now. And actually in order to be able to make it easier to work with this, I am actually going to take this here, then have this completely empty canvas of expression evaluator. Here, what we are going to do is that to find a way to extract this particular PGN starting from this particular move. So I'm going to go ahead and look for the methods provided within this game class. Okay, we have various positions. I don't think we need get method. So I'm going to scroll down a bit. I don't want to go to anywhere. I want to be able to set stuff. Okay, maybe the set current move list, but I am going to be checking for other methods as well. So I don't want to be setting variations or terminations. Okay, this is not very helpful, but I am going to be trying this one. And this method is going to be taking a list of moves, or not a list of moves, but actually an instance of the class move list that has been implemented by this, the external library that we are going to be using. Okay, this now implements list of moves. Okay, I wonder if there is a way I can get the rest of the moves that are going to be played. So here we have the I variable, the integer variable that is going to represent the move that we are currently at. So I wonder if we can somehow use that. So for example, if I type in move, okay, we have get current move list. And here, if I find the 115, I suppose we are going to be looking at, okay, E takes F4. So this is going to mean that here in the main game, E takes F4. Okay, we would like to get the move starting from this point on. So what I can do is that I can actually delete the first this number of elements, if I'm not mistaken. And for that, I'm going to try something extremely ugly, but if that works, that works, at least for a personal project. So I'm going to assign this to a variable, and then we are going to have the exact same list for obvious reasons. Then for the number of moves that we have here, I am going to be starting from, okay, we already have the variable I, so I am going to call this, let's say, J. I am going to start with this one. And until this is equal to I, we are going to be incrementing this. And here we are going to be removing the first item of this list. So we are going to see what we are going to be left with. And I'm going to check if this actually affects this one as well. I don't think so, but I would like to make sure that this doesn't affect it, as I was saying, but apparently it does. But now we actually have king g3 to f2 as the first move, which is this move. So this might as well have worked. So I'm going to take this and stop my application, and we are going to find out together. Okay, it is going to take a while until my application stops. I don't know why. Okay, I'm going to have to force quit because this doesn't work for some reason. And I am going to open this up again, our application, and hopefully I managed to copy the code that I wrote, and I'm going to try that. Okay, this works. And for some reason I cannot, okay, I have to import this. And maybe I can even use this game set fem method if I'm not mistaken. We are going to try that, but just in case, I'm going to keep this here. So I'm going to go back to my downloads file, and I am actually going to delete this, or in Apple's words, I'm going to move that to trash, and then I am going to be running this application again. I'm not going to be debugging it. Okay, now that we had to force quit our application, the port is still occupied, but we cannot run this now. So I'm going to go ahead and type server colon port colon and 8081, let's say, and I'm going to try to run this application now. And here we are going to be seeing that the PGN analysis has started. And okay, for some reason we got a null pointer exception and that we are going to have to debug. So I'm going to stop this application now and run this in the debug mode. And we are going to be setting a breakpoint around here as well. And then when I resume this program, okay, I don't need this anymore, so I'm going to remove that, and we are going to wait for a while because Stockfish is going to take its sweet time to evaluate our positions. Okay, here, for some reason, we cannot conduct an operation of this game variable. So first of all, I am going to look for the expression g, which is the variable, which is the instance variable of this game class, but I cannot even get this object because this is now going to be throwing a null pointer exception. And that is because it was not able to call this game to string method because we messed up the game object, I suppose. So I'm going to go inside this and look for the toString method. Okay, now that we have seen that there are 15 usages, I am going to be typing in public string toString. And okay, this is going to try to call this toPGM method. And for some reason, this is going to throw a null exception. So I'm going to go ahead and click on download sources, and this is going to take a while. And again, I'm going to go back and find this game class. Okay, I'm going to set a breakpoint here, stop my application and debug this again. And again, this is going to take a while, but I am going to cut out these parts so that you don't have to wait with me. So if I go ahead and resume this program, okay, we are going to be landing here. And if I go line by line, okay, this is going to work. This is all of this are going to work. We are going to get the fan. Okay, this is going to work as well. Okay, actually, before even debugging that, I'm going to run this and try to go through this game class that we have been provided by this external library. And I am going to take a closer look at this one. So here in this PGM processor, we tried to write this game, but this didn't work out well for us. So here we called the toString method. Okay, here we have toPGM method. And okay, if I scroll up a bit, we have the stack trace, we have the move list method, and then finally this one. And okay, here I'm going to be set a breakpoint and rerun this application now. Hopefully we are going to end up here. Okay, first here, then I am going to resume this program. I am going to be removing this one because as it turns out, we don't have anything to find out here, I suppose. So here, piece.get piece type equals to none. So the piece is actually none. So this get piece type method is going to be evaluating to a null, and it cannot call the equals method on a null reference. So this is the reason, but we have to understand that how on earth are we getting this non-piece, although we didn't have that in the first place before we manually intervened with the PGN, or let's say the moves themselves. And here we can see that the move we are looking at is this king g3 to f2, which is right. Okay, the king has moved to f2, so this is right. And if I go ahead and open this up, okay, here we don't have any piece information. All right, where do we get the piece? Okay, port.get piece, move.get from. So I'm going to have to evaluate this. I don't know what this is representing. So I am going to type in move.get from. Okay, this is going to represent where the king has moved from. And so far this is okay. And in this board we have, and I am going to make this visual, but as it turns out, this is starting position. So I suppose if we were deleting the moves, the initial moves that we don't want to see, we actually reset the starting position as well. So this is not ideal and this is not going to work out. So I'm going to stop this now and try to figure out why this might have happened. So here I am going to find the part where we have changed the logic. And although I don't think this is going to work, I'm going to try to run this with this line commented out just to be sure. But okay, we again get the same exact problem. So this is not the problem as I have anticipated. Okay, now that I think about, maybe we should not be trying to mess up with the content of this particular library, but instead we can maybe try to intercept at the time of writing this file. So I'm going to introduce a breakpoint here and try to debug this application. And instead of sending over game, which is an instance of this game class that has been provided by the external library, maybe we can try to send over the string value that is going to be written and saved in the PGM file that we are going to be creating. So as you can see here, what this does is that this is going to take every single game in that map. For example, for a bishop ending, we are going to have a list of games. So this is going to try to parse that into a string using the internal method that we have just seen here. And here, if I type in public string to string, and for some reason this is not working. So what we can do here maybe is that instead of passing along a game or a list of game, we can pass along a list of string, which is going to be the exact string that is going to be written into the file. But for that reason, we are going to have to go back one step, and I am going to be finding this line. And here, as you can remember, we are going to be adding this game after doing some stuff, after manipulating that object. But instead of that, maybe we can call this toString method here on this particular line, and we could try to turn this raw string into something that is going to resemble what we have did ourselves manually. So this should actually work quite well. And I am going to adopt the test-driven approach for that one. What I'm going to do is that take this particular string, and now I'm going to close this down, stop this application, and I am going to assume that we have a private method here because this is going to be called by a method within this class. And then what this method is going to do is that it is going to take that PGM file that I just copied, which is going to be a type of string, and it is going to be supposed to returning this PGM content that we have constructed manually. So for that, this is now again going to be returning a string, and I'm going to call this method simplify PGN, and this might actually take the game object itself as a parameter, then it can call the toString method itself. And here for now, I am going to be returning null. And instead of manipulating this move list here, what we can do here is that I am going to be deleting all of these. I suppose we are not going to be needing that one as well. We are going to call this simplify PGM method that we are going to have and assign this to a variable PGN to be written into the file, let's say. And instead of adding this as a game, what this is going to do is that this is going to add a string. And for that reason, we are going to have to change every single one of these. So I'm going to press Command Shift R, which stands for replace. And I am going to be, okay, not this one, but I don't want to lose this one either. So I'm going to retype this map piece type, comma, and then this is going to be a list of string, and I am going to replace them all. Then we are going to have certain compilation issues. First of all, we are not going to be using games here. Instead, we are going to have strings as we have taken here, so we don't have to invoke the toString method either. And I suppose we are going to have to, I was going to say replace these as well, but this is not going to change. Still going to be creating new array lists. And I am going to go through some of the warnings if there are anything that we should be looking for. Okay, this one certainly we are going to have to implement. And here again, I am going to be adopting a test-driven approach. For that, I am going to be creating a new test class using Command Shift T, and using that shortcut, I am going to be creating a basic class that is going to enable me to test this one. And here I am going to be annotating this class with extend with Mockito extension class, if I'm not mistaken. And then here I am going to be injecting mocks for this variable PGM processor. And then we are going to be mocking this stockfish service. And under these, I am going to be writing a test method. And this is going to be package private. This is not going to be returning anything. And here I am going to be testing this simplify PGM method. And inside this method, what I want to do is that I would like to see that this string input, as I will paste here, which is the result of toString invocation for that game we have been working with. And actually, in order to be able to test this, I am going to have to take a PGN as an input, and I am going to have to fix this too. Here, I am going to call this toString method so that this is going to be providing us with this output. And here, as a result, what we would like to see is that the PGN that we have constructed manually here. So I'm going to take this over here and this line with a semicolon, and I'm going to type in PGN. I should have named this PGM processor for conventional reasons. And here I am going to be testing this public method now so that we can test this, simplify PGN. And here, as far as I can remember, this is now named input, and we are going to be asserting that, and actually I'm going to use the static import here. We are going to be expecting this output as a result of this method being called with this input. And now that this is going to be returning null, this is not going to work out well, but we are going to try that and see that failing. And that is the whole idea behind test-driven development. First, you write your test, and as absurd as that might sound, you are going to see your tests fail and then fix your test. And here, if I scroll down a bit, we see that we have certain assertion failed errors. But for example, if this method were to return this, and I am going to do this pretty ugly but informative thing and run this again, this test that has failed is now successful. So we have to implement this method in a way that this output can be produced as a result of this input. So I'm going to go ahead and set a breakpoint here, and I am going to try to implement that line by line. So here I am going to be evaluating expression as always. And as funny as this is going to seem, I am going to stop this application again, because now that I realize we actually have a fem variable here, which is going to be representing this part. And this part has nothing to do with the game itself, but rather this is a property of a certain board configuration. So here we are going to have to send that in as a parameter as well. So I'm going to go ahead and type in board.getFan. And for this particular test, what we are expecting is that we would like to get this exact fan as an input. So I'm going to name this, okay, not input, but rather I am going to match the name of these two variables, or in fact four variables at the end, so that we know what we are working with. Here I am going to name this pgn, and down here we are going to be initializing another variable, another string called fan, and the value of it is going to be this one. And right away you are going to see that not only the simplified pgn is no longer expecting only one input, and no pun intended, we also do not have any variable called input, so I am going to have to type in pgn and fan as we have named them here and at the start of this particular string. So here, first of all, we are going to have to see that this test fails, so I'm going to run this again. And as funny as this may sound, this is how test-driven development works. Again, you see your tests fail and then you fix them. So I'm going to go ahead and debug this. And as you can see here, we have this pgm variable and fan variable that is going to be accessible inside this simplified pgm method of this pgm processor class. So I'm going to evaluate expression, and I would like to write such a code, such an implementation, so that the output of this particular method is going to be exactly this one. So I'm going to start by initializing a string builder. You can call this builder or string builder, this doesn't really matter. And I am going to be using the empty constructor of this class. And as you can notice, the first characters that we are going to be needing before the fan variable are these 6 characters. So I'm going to take them with me, string builder.append. And here you can pass in many different types of variables, but we are going to be passing in a string, but I will also have to escape this quotation mark. And after that, I am going to be, okay, first of all, I am going to have to end that line, string builder.append. Then we are going to be passing in this fan. And right after that fan ends, we are going to be passing in something like this. And I suppose the number of new lines are not going to matter, but we are going to find out. And just to make sure that we can see what we are working with, I am going to make these bigger. And here I am going to be appending this particular string. And again, I am going to have to escape this. And I am going to be evaluating this expression so that we can see what we have so far. Okay, we have this fan metadata as well as a space at the end as have been specified here. So I suppose this is going to work just fine. And now what we are going to need is that this particular PGN, as you can see here. And I have tried to play with various methods that come from the game object itself, but I don't see a very reliable way of getting this particular PGN using the class that have been provided by the external library we have been working with without actually breaking its internal implementation. So here we are going to do something slightly ugly, I will have to admit, and we are going to have to parse string, and I am going to show you what that means. So first of all, here I am going to paste in what we have implemented so far. And as you can imagine, if we somehow get to append the rest of the PGN, and obviously we are going to be implementing this, and when we return the string builder.toString, we are going to be good to go. But some way or another, we are going to have to get this, which is going to be this part. So I'm going to rerun this in the debug mode again. And the reason I stopped this application is that I wanted to be able to work with a much more clearer workspace, much more clearer code fragment in the IDE's choice of word. So here, if I go ahead and inspect the PGN, what you're going to realize is that we actually have the 59 king F2 move. And as you may remember, we had the move count 115 in our debugger. So if we were to pass it into the simplified PGM method so that it represents the number of moves that can be removed from the start, we may actually be able to achieve the thing that we are trying to achieve in the first place. So I'm going to close this down, stop this application, because I'm going to have to change the method signature. Here I'm going to be taking in, let's say, move from, or let's say moves to be deleted. And here, when I'm calling this method, I will be passing in this variable I, which is going to be indicating the number of moves that needs to be thrown out. So here I am going to be passing in I, but in this particular method, I'm not going to call it I because it's not going to make any sense. And here I am going to be initializing a new variable, because as you can see here, now this is not going to compile because of the mismatch between the number of arguments being expected. Here I am going to type in move number 115, and I am going to be passing it in the test method as well. And now all I have to do is that I have to use this pgn string as well as this integer number to be able to extract this particular substring that we are going to need. So I'm going to go ahead and evaluate expression as always. Now using this number 115, what we need is that we need to be able to find out that we would like to start with the move 59, and this height we are going to be looking for is white. And if you are not familiar with chess notation, if this were black to move, this would have been something like this, which would have meant that black has played bishop d7 as the move 59, and then we proceeded on to the move 60, 61, so on and so forth. So for this one, I am going to create another method actually, because I would like to properly test this. And what I mean by that is that I am going to be having a method that is going to be returning a string such as this one, or maybe this one, or 59 with 3 dots. And I'm going to call this method extract PGM part of interest, let's say, but you can get more creative than that. I don't think this is really that easy to understand at first. And I am going to be passing in this PGN as well as this moves to be deleted variable that we are going to be able to pass in here. And as you can imagine, if I replace this string with a call to this particular method, extract PGM part of interest, and then I can pass in PGN and moves to be deleted. If this were to return this line as a result of these PGNs and move numbers, and also if it were able to understand when it's black to move as well, in that case, the move number is going to be an even number, and we are going to have to test that too. Again, as you might imagine, the simplified PGM method is going to be working just fine. At least that's what I suppose. And for this one, we are also going to be adopting a test-driven approach. So first of all, I am going to be returning null from this method. And here I am going to be creating another test method. This is not going to be returning anything, test, and I'm going to copy the name here, no parameters. And when I provide this particular PGN, and I'm going to make this a class variable because this is going to be shared across all the tests we are going to be writing. So private static final string. I am going to call this PGM with all caps as per convention. And here I suppose we are going to have certain overlaps. So I am going to be deleting these one. And here, this is no longer going to be able to find PGN. So we are going to replace that. And what I would like to assert that I will get this particular output as a result of, okay, let's first write this one. So I'm going to type in output, and then I'm going to be typing in PGM processor, extract PGM part of interest. Then I'm going to be typing in PGN, and here we are going to be initializing another variable. You can also type in the value right here, but I think this is going to be much more intentful and understandable, especially for the developers other than me who may read this method. And similar to this method, and I'm going to call this one, I am going to be creating a similar test case in which I am going to be starting from move 116. And here I will be expecting an output like this. And if I were to do lots of tests that are going to be looking like this, only the parameters are going to change, then what you can use is you can use this parameterized test annotation. But I think that this is going to be an overkill in this case now that we are going to only be testing 2 cases. So there is that. So here what we are going to do is that, as always, we are going to see these tests fail. So if I go ahead and run this test class, what you are going to see is that all of our test methods are going to fail, and those are going to be assertion fails. For example, in this case, if I manage to make this full screen, we were expecting a PGN like this, but we only got this fan property and then null for some reason. Or for example, if I go ahead and here I don't even have to click on this because this was expected to produce a result such as this one, but the actual value that was provided by this method was null. So now we are going to have to fix those service methods, and I suppose we are going to be good to go. So I'm going to close most of these down so that it's much more easier to work with this project, as it is quite hard to navigate through this project right now. So I'm going to open up this PGM processor test, scroll down a bit, and here, first of all, we are going to have to implement this particular method. And I suppose if we implement it in a way that we should, then this is going to work out as well. So I'm going to go ahead and debug this particular test method. And now that I haven't set any breakpoints, this just ran and failed. So I'm going to set a breakpoint again and try to re-debug this again. And this time around, we are going to be landing here. As always, I'm going to be evaluating expression. Now the challenge is we would like to get this particular string using this PGN string. And if I go ahead and view the string going, we are going to see that we have lots of metadata, we have lots of moves here, not only that, but also certain timestamps. So somehow we are going to have to handle them all. And I'm not sure, we might actually use this information, though we are not going to be able to test this. This might actually prove to be useful for my real life use case. So the challenge here is that using this move number 115, we are going to have to understand two things. First of all, this is white to move, and also we should be starting from the move number 59. And it is actually quite easy if we should be using dot or three dots, or in other words, if it is white to move or black to move. And what we can do here is we can actually conduct a very simple mathematical operation as follows, which is going to tell us that if this number is an odd number or an even number, and if this is an even number, we are going to go with white, or in other words, single dot. And here I am going to be using the ternary operator. And if this is false, then we are going to go for three dots. And if I evaluate this expression, okay, now this is not a Boolean value, so I'm going to have to check if this equals to 1. Okay, now this is going to evaluate the dot, which is what we like for this particular value. And if this were to be 116, then this would have been three dots, which is going to work well for our test case as well. And the second thing we are going to have to infer here is the number 59. So for example, if I go ahead and divide this number by 2, we are going to get 57. But here we are going to do some simple math as well. For some numbers that come after each other, we would like to get 59 for both of them. So I'm going to find those numbers. And the first one is obviously going to be this one. And the next one is, I suppose, going to be this one, because if I divide 117 by 2, then this is going to be return 58. So what we are looking at is that we are going to need these two numbers. And now that we have 115 and 116, I suppose we are going to have to add 3 to this variable in order to be able to get the number we are looking for. So what I'm going to do is that to close all of this down, and also I will be copying that so that I can reuse it here. And here, instead of moves to be deleted, I am going to call this move number, because we are no longer going to be deleting anything. And I am also going to be renaming these as well, move number, move number. And this is going to be our dots part. This could be either 1 dot or 3 dots. And for the move number, we are going to have to do something like half move number, and then we are going to be adding 3 to the number we are being provided, and then we are going to be taking into a parentheses and divide that by 2. Okay, now that this is an integer, I should be assigning this to an integer as well. And when I try to add these two variables into each other, this is going to evaluate into a string, no problems. So here I am going to assign this to start half move number plus dots part, and I am going to be returning null, and I am going to be debugging this again, but right before the return line. So I'm going to go ahead and debug this, and instead of moves to be deleted, we are going to have to type in move number. And if I evaluate expressions now, what you are going to see is that our start is 59 dot, which is our expected output. So what I'm going to do is that I am going to find, if this beautiful angel lets me, I am going to be finding the index of particular start. And this is actually quite ugly. You really don't want to do this in Java, especially in a language that is very much popular with its object-oriented approach. But in this case, I have to. So that's why I'm doing this. I'm not proud of it. And actually, I can assign this to a start index integer. And here, if I try to get substring from the beginning index, okay, now that it is called begin index, I'm going to do that too. Not that it matters technically, but from a perfectionist point of view of mine. So I'm going to evaluate this, and we are going to see that we get this string as a result, which is going to suffice, I suppose. So I'm going to stop this now. And here I am going to be returning pgn substring from the, okay, here I am going to have to initialize this begin index variable, pgn index of start, then we are going to be using that begin index. And although these tests are going to fail, what I'm going to do is that I am going to debug this now. And here I'm going to set a breakpoint, remove this one, and then resume the program. And I am going to see what this is going to be evaluating into. And if I view this now, I suppose this should now work on Lichess. So I'm going to go ahead to Lichess, and not the API, but the website itself. And under Tools Analysis Board, I am going to be pasting this PGN in. And this actually work out the way I wanted, starting from this particular board, and it goes all up to the end of the game. And just to be sure, I am actually going to delete this one as well, and I'm going to run my application just in a normal mode. And if I find the time, I will have to fix these test methods as well. And here I'm going to pick out chess application and run this application now. And again, this is going to take a while until it conducts all the analysis required. And it actually saved one game to this file we are going to have access to. So I'm going to open that or not. So I'm going to drag that into IntelliJ. And here I am going to be copying this into Lichess again, and I'm going to refresh this page. And when I paste it here, okay, this is going to work just fine, and this is exactly what I need. And I am actually quite happy and proud to have achieved this. This has been much more challenging than I expected, to be perfectly honest with you, especially with this little angel roaming around. I do remember that we also have to implement a REST API that is going to be taking a multi-part file as an input so that we don't have to readapt our application YAML file every single time I would like to process a PGN. But we are going to have to ask for your understanding for that one. I really hope that you found this video helpful. It was actually quite hard for me as well. And he is going to lick my face because he has been missing me because I was busy teaching you. So yeah, I thank you for your time, and this is exactly how I would go about working with a library with documentation that I need to use. As always, please do leave a feedback if you have watched so far. I again thank you for your time, and we would like to see you in the next video. Take care.